For 30, we have a tetrahedron, which is a four-sided triangular pyramid. A triangular pyramid.
Yeah. You good?
Yeah, I just dropped my book. Tetrahedron looks like that.
Yeah, I know. I saw a picture of it on your.
Yeah.
Tetrahedron. Just a four-sided dice. Okay. Give the probability model for rolling such dice. So you're making it, remember, a probability model is sample space and then the probability of each of those happening. So what are all the possibilities when you roll a four-sided dice? You can get, no, you're rolling two of them though. So you get a 1 and a 1, you get a 1 and a 2, you get a 1 and a 3, or you get a 1 and a 4. 2 and a 1, 2 and a 2, 2 and a 3, 2 and a 4. A. So there are 16 possible combinations. So you have a 1 in 16 chance of rolling each of these. We think this is at least close to correct because we're assuming that each of the sides comes up equally, and we've made the sample space, and each outcome is equally likely. What? Yeah, that was English. What's the probability of rolling a 5? More than that. It's 4 out of 16. Right, 4 and 1, 3 and 2, 2 and 3, 1 and 4.
It's out of 4, right?
Yep. Okay, any other questions on the homework assignment?
No.
Okay.
No.
All right, then let's go back to our notes. All right, we got to example 5 yesterday. And I probably should have done example 6, but I didn't. Okay, the following chart represents marital status. Find the probability of not being married. So there's 2 ways to do this. You can add up all the categories that mean not married, because there's multiple. You can add up never married, and widowed, and divorced. And that would give you the probability of not married. Or, we know that this has to add up to 100%. Take 100% minus the probability of being married. And you get 0.548. That is the exact same answer you would get if you added up the 3 options instead of doing the 1 minus the 1 option. That is the complement rule. It has to be the complete complement of it. Not married and married have to add up to 100%. Because those are the only 2 options. You're either married or you're not. Okay, questions? That would be the whole. All of the women are the one. We're taking away the people who are married, and we're left with the ones that are not. Okay. Example 7 is called a two-way table because we have columns that have multiple options, and we have rows that have multiple options. The last row and the last column are totals. So 12 is the total number of face cards, 40 is the total number of not face cards, and 52 is the total number of just plain old cards. 13 is the total number of hearts, 39 is the total number of not hearts. And again, 52 is the total number of cards. Okay? How many cards in a deck are not hearts?
30.
39. How many cards are not hearts? How many cards in a deck are hearts and face cards? 3. How many cards in the deck are hearts but not face cards?
10.
Good. How many cards in the deck are face cards but not hearts?
9.
9. Excellent. That's how you read a two-way table. And then our 30, which I didn't ask about, the number of cards that are not face cards and not hearts. That would be 30 cards. Okay. Find the probability of P and B. So event A is up above getting a face card, and B is getting a heart. So you're looking for the probability of getting a face card and a heart on the same card, so at the same time. What is that probability?
312.
Not 3 out of 12. 3 out of 52. There are 3 cards that are face and heart at the same time. There are 52 cards total. You have a 3 in 52 chance of picking up one of those cards. Okay? For P of B, A, or B, so we're looking for the probability of getting a face card or a heart. So this widens it a lot. You're a winner if you draw a face card or a heart.
12 out of 52.
Little high. More than 12.
What's that about? A face or a heart?
Uh-huh.
So we're adding 13 plus 12?
Sort of. It's 22.
You don't count 3 twice. Yeah.
There are 13 hearts and 12 face cards, but this 3 is in both columns,
I knew that.
so we don't want to count it twice.
Right? You knew that too, man? Yeah.
So we're looking at 22 out of 52.
You're not allowed to do that.
Another way to look at it is to not use the totals and just add up the hearts and the face cards, and then you see, oh, I've got a 10 plus a 3 plus a 9. Okay, questions there?
Nope.
Yeah, I already had that answer. Why do you just draw a heart?
Because I have my pink up here and then a pink down there. I can draw a heart and a face. Okay. This is the addition rule that you just did. If you're looking for the probability of P or B, you take the probability of A plus the probability of B minus the probability of them both happening. So in our case, with face, heart, and heart, the probability of picking a face card was 12. The probability of picking a heart was 13. But the probability of them both happening is 3. And we don't want to double count that. So you do 12 plus 13 minus 3 because that's double counted.
What is he? Getting the hook?
Yes.
I know, but show you how to do it.
Should have done it last week. Do it as soon as possible. But not during the notes.
Probably not the common answers.
I think everybody forgot their answers. They just retook it.
I didn't forget mine.
on it, so
I didn't hear them.
I failed. Luckily, I still have an A. I was telling my parents that I had an 89 in my stats class, and they go, "Oh, I bet your teacher just made it barely an A, so she didn't have to hear from you."
No, I don't do
I
that.
told them that you wouldn't not do that, and they were like, "Uh-huh," because they know that I don't get happy when I have D's.
I know. Okay, we're gonna add a new event, which is C, and that's drawing an ace. So we're doing P of a heart and an ace. And remember when the and means at the same time. So what is the probability of drawing a heart and an ace? Nope. One card.
17 out of 52.
What?
Nope.
19 out of
Somebody said 13, somebody said 17.
1 out of 50. Yeah, it was 1
One. There is only one card that is both a heart and an ace. You guys are all thinking or. You're thinking or. You only win if the card is a heart and an ace.
Got it. Well, the number, letter B.
Yes, correct.
So,
So next one is a heart or an ace.
17. 13. 17. 17 or 15. Wait.
There are 13 hearts and 4 aces, but
It's
one is double counted
Wow, how's one double count?
because the ace of hearts is in both of those categories.
So is it 16?
13 plus 16 out of 52. That's why we did the and one first, so we knew how many would be double counted. Put your phone away. Okay, does that make sense?
Yep.
Okay. So let's talk Venn diagrams.
Okay. Let's talk.
Venn diagrams are
I didn't win.
more fun in math than they are in English.
Really?
Sure.
Yeah, because you don't have to write sentences in them. Just put numbers in them.
I don't write sentences, I know.
You're supposed to.
I don't
Alright.
see the little circle thingies to make the Venn diagram.
Yes, you're capable of drawing the circles.
That's not straight.
Better? Okay, draw 2 circles, label one of them A and one of them B.
How big do I need my I've never drawn circles before on camera. Why are they overlapping?
I don't have my style.
It's a Venn diagram.
No, they're not together.
So if they're not, use your select tool and then you can move them.
Okay, well now I've just drawn like.
It doesn't want to move. Why not?
For what? For what?
A was
What?
face card.
Yeah.
You have to draw it. All right. So in a math Venn diagram, we're just gonna write the number of things that are in the space. So always, always, always start with the intersection because it's the easiest way to do it.
Like that.
Otherwise, you have to change your answers. The inside, the middle. How many cards are both face cards and hearts?
52.
No, they're both face cards and hearts. You guys are killing me.
12.
3. King of hearts, queen of hearts, jack of hearts.
3.
3 cards that are both face cards and hearts. That goes in the middle.
I said that. I said that.
All right. How many cards in the deck are hearts?
13.
13.
Yeah.
So what number do we put here?
13.
Oh, we put 10. The whole circle has to add up to 13.
Yeah.
10 and 3.
I like Venn diagrams.
Okay. How many face cards are in the deck?
12.
There's 12 face cards in the deck.
Yeah, he said 3.
So we've got 12 cards in our face circle. 3 of them are hearts. None of them are not hearts.
Yeah.
Not so hard, right?
What am I supposed to use this for, though?
Stats class. How many cards are outside of these circles?
52 minus 10, 3, and 9. 52, yeah. 30.
30 cards don't fit anywhere in those circles. Like your ace of spades, that's outside. It's not a face card and it's not a heart.
30.
Okay, so what's the probability of getting a face card?
3. 12. 52. Yeah.
What's the probability of getting a heart?
13 off 52.
What's the probability of getting a face and a heart?
3 out of 52. Too slow now.
Okay, so that's how we are going to use Venn diagrams. You're just going to put the number of items in there instead of listing them all. You could, Michael, stay with me. You could list, ace of king, king of hearts, king of spades, king, whatever, but that's going to take you forever. Tidwell, you just make everything take longer than it needs to. Like it was quick and over, we were done. All right, complement means not. So when you see A to the C power, that means not A. Okay, so I want you to draw a circle in this box. I want you to label it A. So let's say that A is drawing a face card. That means the complement of A is not drawing a face card. So I want you to use your highlighter. My highlighter doesn't work on this computer, but you're going to shade in everything that's not in the circle.
The what button doesn't work?
The highlighter doesn't work on the PC because I don't have a touch screen. Shade in everything that's not in the circle.
Okay, why?
Because that's the complement of A. Everything that is not A is shaded.
Circle.
If A is being blonde, everything that's not blonde is the complement of A, not shaded. Not blonde, being shaded.
Not blonde.
Okay. For the next one, you're going to draw 2 circles and overlap them. Label one of them A and one of them B.
It's a Venn diagram.
Yep, a normal looking Venn diagram. This one is the intersection. The and, A and B. And it uses this little symbol here that looks like an A with no line. That's how I remember that it's and, because it looks like an A with no line. The intersection is actually where the 2 circles intersect. That one actually makes sense. So you're going to shade in this middle region.
I'm guessing we're going to need another circle.
2 more in the next one.
Cool circle.
All right. And the next one, 2 more circles labeled A and B.
Getting wild now here.
This one is the union. The symbol for union looks like a U. Easy to remember. The union is all of them. It's the or. So it's everything in A and everything in B and everything in between. The union of the 2 circles is everything contained within those 2 circles. Union is or. That one's harder to remember. And looks like an A, or looks like a U. All right, and the last one. If two events are mutually exclusive, they are disjoint and they don't have anything in common. So for this one, your two circles don't intersect because they have nothing in common.
Segregation. And include.
So the example I used earlier was if A was being a freshman and B was graduating. You cannot be a freshman and be graduating. Now, I didn't use age. I used class because your class is based on your credits. So you could be a 14-year-old senior, but you can't be a freshman and graduating. Those two things are not, they are disjoint. There's nothing in the intersection. Alrighty, questions so far?
Nope.
Okay,
Oh, how was I know?
we have another assignment for today.
Oh, no.
Dang it.
It's this one, 7.2.3 or 4, I don't remember which one. Some
Three
days work.
pages, so.
That's because I gave you space to work.
I don't know. I guess the roller wheel does take off some space.
Alright, you guys at home have any questions?
No.
Wonderful. Okay,
Or TikTok thing.
alright.